first speaker series for the year 2019. And today we do have a speaker, Mr. Konak Modi, who is a tech lead from Glitch Munich. They have an excellent product, which basically is built on the privacy values, and they do honor the end users' privacy. And today's topic is going to be privacy by design. Like most people uh, doesn't know about it, but right now we could see emerging issues regarding privacy after the post Snowden era, and most people they just take care of privacy either by working using encrypted communication, but how to build products which value the end user's privacy when they are built into them rather than after uh, using them. Konak, you can start.
Right. Thank you for the introduction. Good evening, everyone, and welcome to the session Privacy by Design. My name is Konark Modi, and I currently work with a company called Clicks, based out of Munich, Germany. For those of you who are not aware of Clicks, we are actually pretty big in Germany. Clicks is primarily a privacy-friendly search engine, and we also have a lot of privacy-friendly features like anti-tracking, ad blocking, anti-phishing. And we package all of these features within our products, which is basically our browser. So you can download Clicks browser and use. And as soon as you start typing in the URL bar, the search results are shown in the dropdown. Apart from that, we also have some extensions like Hostry. And overall, like for the past few years, we've been working on developing privacy first technologies, especially when it comes to collecting data on the internet. Now, every one of us is aware that sharing credit card numbers or passwords over the internet is not a good habit. But yet there are some people who unintentionally or carelessly end up sharing such stuff. Just a word of caution, the next few slides might be a bit disturbing or a bit fun. It depends on how you take it. So let's see. So there are some people who get way excited when they get their new credit cards. So if you follow this Twitter handle, I need a debit card, you can occasionally find people posting their pictures when they receive a new debit card. And if you're lucky enough, you can also see a picture of the back of the card, so you can actually transact on any website just visiting this Twitter account. Then it's always told to take out post-its and clear your whiteboards when you go online. But again, there are chances that some people are careless and they leave username passwords on the whiteboard or on the post-its that are behind. But then looking at these leaks, there was this guy who thought it's a brilliant idea to upload the bank statement on a website. And the website actually is used to upload documents and enhance the visibility of the document itself. So when this person uploaded the bank statement, you can see there are already 350 views for the statement. And because it's a website to promote your content, it already categorized it and made it searchable based on whatever parameters, right? And now I assume a lot of us are thinking that this is pretty nasty, this is pretty bad, and the users should not have done this, which is true. But even if our users are careless, this does not mean that websites, apps, and corporations can operate with the same negligent manner or careless manner. Just to give you an example, so this is a pretty popular website, HackerOne, where you can submit bug bounties for various security programs. And they have this page where you can actually download some reports. Now, in this video, a small video, it's basically, I have an extension, which I'll share later with you guys. It's basically, you can search whatever has been leaked by a website to which all third parties. So for example, I have the extension installed here, and I go here and search whether my personal email ID has been leaked to any organization while I was transacting on the internet. So right now, it says 0 websites have leaked my information to 0 different companies. But then I went on this website. I did the simple form filling, which is like a pretty common behavior on the internet. I put my name, last name, my email, and my company name. And then I just clicked on the download button. Right? And this is what you need to do on various websites. And this gives you a link that, hey, thank you for downloading and stuff. But in the background, what actually happened was all the information that I entered in the form has actually been shared with n number of different companies. If I look at just my email ID, this email ID, by just putting it on one form on the internet, has been already shared with Amazon, Google, Twitter, Microsoft, and Marketo. And you can see how it has been leaked, right? Now, as a user, all I wanted to do was just visit this website and download the report. But because of presence of a lot of third-party trackers on this, this sensitive information about me has already been leaked to all these companies, right? Moving on to the next example, which is Mozilla itself in this case. So if you've ever donated to Mozilla, what happens is after you have finished your payment, they open this thank you page. On this thank you page itself, they have some query parameters in the URL. For example, the amount you paid, the currency you used, country of origin, and specifically the email address you used to make a payment. And because this page also uses third parties to load content like fonts from CDNs or Google Analytics for their analytics purposes, in this case, because the referral is not clean, the same level of sensitive information is also leaked to these third parties. In this case, googleapis.com. Then there is another popular website in Germany called Flixbus, which is used for booking bus travels. And again, because it's loading some fonts from Google APIs, but on the booking page, it actually leaks my order ID and my download hash, which basically gives access to anybody to my complete booking. Then Lufthansa is no exception as well. Again, it leaks my booking ID and my last name, which is essentially the only two required parameters for anybody to open my booking, to a bunch of websites like WebTrends Live and Exact Tag. And they basically can access a lot of personal information once they have these two parameters with them. Then Spotify earlier this year was doing the same. Basically, if you have a Spotify app and you click on open my account, it opens your default browser and it basically has this referrer which has your OAuth token in the URL. Now, because that page also uses a lot of third parties like Scorecard Research, Facebook, etc., they were all getting your OAuth token. And anybody who had access to this URL could basically log into your Spotify account, check your date of birth, are you a paid member or not, and other things. Now, I can go on and on about such examples. To be honest, it's actually a rarity these days to find a website that is not leaking your private information rather than it being the opposite, which is the more preferred way the web should be. But today I'm not here to criticize how websites are using these third parties. Rather, I would like to dig deeper into why these websites are leaking this info. And if you are to create your own service to provide analytics or recommendations, how can you build services in a privacy preserving manner without having to snoop on the user's activity? Now, the larger picture is if you are a website owner or a blog owner or an app owner, you basically want to do analytics, content delivery, have app performance, audio measurements, goal conversion, etc. And from day one, you will not write your own service, right? With the advent of software as a service, it's very easy for the developers to just sign up to a service like Google Analytics or Facebook tracking and implement that on your website. Now, once you start doing that, let's see how you enable tracking on the web. So let's say you are a website owner and now you want to put analytics on your website, right? So to put the analytics on the website, these are the use cases you are looking forward to solve. You want to see how many unique visitors are coming to your website, what is the source of traffic, what are the number of page views, time spent, bounce rate, etc. And to do that, you choose an Analytics X as a service to do that. Now, what Analytics X will provide you is a dashboard where you can check in real time what is happening and a code snippet that you need to embed on your HTML pages. Now, once you do that, let's say you are the owner of hotels.com and now you have Analytics X being used on that website. Now, on the right hand side, you will see what Analytics X will collect. And on the left side, you will see what happens when the user interacts with the website that has Analytics X. So let's say Alice, a user, visits hotels.com. And because hotels.com has Analytics X, it will generate a cookie on the client side and send this value back home, which is basically at this time, cookie value A visited the website hotels.com. Now, when Bob visits the same page, hotels.com, because Bob is also visiting for the first time, it will generate a cookie on Bob's machine, cookie B, and send this value back home, B hotels.com at this time. And now when, as you as the owner of hotels.com, log into your analytics dashboard, you will be able to see how many unique visitors did I have, and the answer is 2. But what we normally forget is build.de, which is another website, also uses Analytics X. So if Alice visits build.de, because Alice already has a cookie for Analytics X, the same cookie value will be sent with this particular website, in this case, build.de. But as normal website owners, build.de will only see how many unique visitors did build.de has, which is 1, and hotels.com will see that they had 2 unique visitors. But actually what is happening is Analytics X as a company can see that hotels.com and build.de are being visited by a person with cookie A, and hotels.com is only visited by a person with cookie B. This pattern of data collection is something which we call as server-side aggregation per user. What that means is all the data is sent on the backend, on the server side, and on the server side, you perform your jobs to do aggregations per user. In order to do server-side aggregation per user, you have to send the records in such a way that they can be linked on the backend. There is no way around it. And for the records to be linked, client needs to send an ID with the data that it's being sent. And what will happen is this method will produce side effects because now you can link multiple messages side by side. As an example that I showed earlier, now you basically can see that Alice is the same user who first visited hotels.com and then visited build.de. This data that was being used to count unique visitors can now also be used for doing profiling or retargeting. So for example, if Alice visits build.de now, most likely Alice will be shown with an advertisement that says, hey, by the way, you were looking for such and such hotel for such and such location. Now, this was a very simple example, right? You would say, so what's wrong with that? All Analytics X knows is that this is a cookie value, which is visiting different domains on the web, in this case, hotels and build.com. But now I'd like to actually show you a real use case, real life case where websites can actually de-anonymize a user based on the same data collection pattern. For this case, we'll take an example of Google Analytics, not because we have something against Google Analytics. It's just that everybody understands the use cases of Google Analytics as it is the most popular analytics service being used on the internet right now. As a matter of fact, in one of the studies we did at Clicks in 2016, we found out that 44% of the page loads have a Google Analytics call. Also, Google Analytics pays a lot of emphasis on your privacy. For example, it does not have third-party cookies, which means tracking by cookies is not possible on Google Analytics backend. But we will still see how, because of implicit sessions, it is still possible for Google Analytics to correlate your website. And you don't have to think about just Google Analytics in this case. It can be any analytics service that can be doing the same thing or even worse than this. You could actually try out this by using this extension, Local Sheriff, install it on your machine and visit your most popular websites and follow the steps that I am going to follow next. So let's say the user visits spiegel.de. Now, in this case, when spiegel.de is loaded, it has Google Analytics call. So apart from various parameters that will be sent to Google Analytics backend, 3 main parameters are your URL, the URL you visit, time you visited the page at, and of course the viewport resolution, which is the resolution of your browser, not your screen resolution. And if you combine viewport resolution with the IP for a short duration of time, you can actually fingerprint that it's coming from the same machine. Then let's say the user visits another website, which is foodora.de in this case. So foodora.de in Germany is pretty popular to order home delivery for food. And if you've ever ordered food online, the primary thing that you need to enter on the website is your address where you want the food to be delivered, right? Now, what happens is on foodora.com, foodora.de, when you enter the address, it reverse geocodes your address and converts it into lat and longitude values. And they put these lat long values in the URL itself. And because this also has Google Analytics script present on it, the URL is sent as is to Google Analytics. And again, the other viewport resolution and the timestamp. Similarly, let's say you visit booking.com and you want to check your reservation. Again, the same thing happens. Booking.com has few query parameters. It has Google Analytics, so the URL is sent with timestamp and your viewport resolution. Then you visited Imgur. Let's say you checked your dashboard for analytics for Twitter. Then let's say you wanted to manage your flight booking. So you visited all these 5-6 different websites in a span of some time. And this is what it will look on the backend of GA, Google Analytics in this case. Now, based on just this UID, it is enough for this backend to track that this is the same user who visited these different websites, Spiegel, Foodora, Twitter, Booking, Emirates, etc. But if you pay attention to these two URLs that I'm going to show, so for example, this URL itself, the structure of the URL is analytics.twitter.com/user and my username. Now, if you copy paste this URL in your browser, you will be redirected to a login page, or you will be redirected that you cannot access this page because this page belongs to me. But because there is GA present on this page and the URL is sent without being cleaned, it is for sure known that the person who visited this page is actually Konark Modi. Then the second page is from this website called emirates.com, which basically, so whenever you book a flight, you get an email, thank you for booking. And if you want to manage your booking, just click on this link. Now, if you recall the process and if you click on the link, it just opens your booking, right? Now, in this case, Emirates had some query parameters in the URL, which was last name and booking ID, which is the only thing required for anyone to access my booking. And they were sending this URL itself with all this information to Google Analytics. And basically, whoever copies and pastes this URL in their browser, they will be able to access my complete booking, along with sensitive information like my full name, my date of birth, my passport, my nationality. They can actually also change my booking, cancel my booking, or put a fake passport or whatever. And this URL is not just being shared by Emirates with Google. There are actually 14 different third parties who get access to this URL. A lot of parties that I had not even heard about, for example, Boxever, Qubit, and services like these. But at this point in time, all of these services have access to my airline bookings. So coming back to the G example, now earlier I showed you like based on this UID, GA backend can track the users, how the user is visiting across different domains. But because of these URLs, which are revealing much more information like your address, your name, and your sensitive details like passport, nationality, etc., they can also be used to actually de-anonymize the user itself. So in this case, based on these three URLs, whoever has access to this backend can very easily see that all these pages have been visited by this person called Konark who lives at such and such place. Now, it's not something which is unique to Google Analytics. I've already mentioned this before. This is not something which is unique to Twitter or Emirates or the 5 websites that I showed. It's actually happening all across the web. So if you visit some medical websites, some books, shopping, news websites, dating apps, even if you visit your bank websites and log in and check your account, such things are happening. Presence of third parties there on each website. The URLs being shared with these third parties are not being cleaned, and hence we are jeopardizing the user's privacy at the end. And imagine this, you might say that, okay, this analytics company has a privacy policy and they do not use this data, but companies change their privacy policy now and then, right? This data can be sold. Let's say the company gets acquired by some other company, then the data that was collected before can also be used by someone else. What if somebody internally to the company tries to sell the data by himself or herself? Or let's say the company gets hacked or company gets a subpoena from the government that you have to submit your logs for last 1 month or so. So imagine this data stream that I showed you earlier. Imagine this, that instead of Google, some random person now has access to the data stream and the kind of damage they do, right? So is this like some evil plan of companies to snoop on your data? Actually not. We think it's companies have legit use cases to solve, but the way data is being collected is actually harming the user's privacy. For example, as I mentioned earlier, like one of the key parameters, key use cases of Google Analytics to solve is how many unique visitors are coming to your website, right? Any analytics service you pick wants to answer this question. And if an analytics company does not have this last column, which is the cookie, they only have this URL and timestamp, they cannot answer this simple question whether it's 4 people visiting spiegel.de or it's 1 person who visited spiegel.de but visited 4 times. So even this basic question, how do you solve it? And that's why the companies need to append some information with the value, with the data they send. In this case, the cookie might look like combination of your viewport resolution and some value. And using group buys on this cookie value, they can answer the question that they were actually 4 visits, but done by 3 unique users, right? But as I showed, the same data set that was used to do unique counts can now actually be also used to track how a user moves across the web and also be used to actually de-anonymize you on the internet. And that was not the intended use case. The intended use case was solving unique visitors, right? But somehow the websites who implemented the services and the services company itself have put themselves in such a position where they're compromising users' privacy. So this brings us to the important question: what can we as technologists or developers or hackers do? We usually ask these questions around, and the most common answer we hear is, let's stop collecting data altogether. That should solve the problem. But we kind of beg to differ on this, because if you stop data collection in this digital age where you want to build data-driven products, you will not be able to do that. Second, all the companies who already have data about you will still continue to exist. While you, if you want to innovate, you will not be able to do that because you are not collecting any data. What we actually need to do is we need to change our mindset and we need to become more responsible while implementing and designing such services. What that means is we have to think from 3 parameters. One, the users, second, the websites, and third, the services itself. Now, when we talk about the users, we have to put users' privacy first. Any data point that can be used to de-anonymize a user should not leave the user's machine. The user should not have to choose between privacy and usability. They should come hand in hand. The user should be able to always opt out and should be given full control of their data. And the user is not supposed to be profiled on the server side. You can do whatever you want to do on the client's machine, but if you are able to create profiles on the server side, you are creating a hazardous environment in terms of privacy of the user. For site owners, we need to build services which still let them solve their legit use cases. For example, how many visitors are visiting my website? How do I recommend the best products to my users? How do I measure goal conversion? Site owners themselves need to take more control over third parties and need to ensure they are following all the good practices when they enable a third party on their website. For services providers, again, they need to collect data which is free from any kind of identifier. It could be an explicit identifier like a cookie which persists for 5 years, 10 years. It could be implicit IDs, for example, combination of IP and viewport resolution. It could be network fingerprinting, for example, doing TLS fingerprinting or doing fingerprinting based on IP and the user agent. So the services need to design their backend, which is free from all these kind of identifiers, but yet deliver the legitimate use cases, for example, analytics. Also, they should not depend too much on privacy policy in the sense that, yes, we do collect the data, but we do not save it, and it's mentioned in the privacy policy, because as I mentioned earlier, the privacy policies often change. And once the privacy policy changes, you can play around with the data that you've already collected with however way you want. Now, if you're a developer and you want to implement a third party on your website, make sure you actually look into the aspect whether you have the resources to host that as a first party solution or not. As a common example, if you want to do analytics on your website, so instead of Google Analytics, can you host a privacy friendly alternative on your own website? For example, Matomo Analytics is one of the examples that you can use. Secondly, ensure that all the private pages on your website, uh, when I say private pages, I am talking about pages which are not behind a login screen, but actually have some sort of personal identifier. For example, the cases that I showed in case of booking or donate pages and stuff like that. Make sure that you have a proper robots.txt and each individual page also explicitly mentions no index tags so that they cannot be indexed by the search engines. You need to limit the presence of third parties itself on the private pages. Any page which you do not want to share outside the company, or any information that you do not want to share outside the company, should not have a third party in the first place. Even if you are putting third parties on that page, ensure that you are using proper referrer policies to clean the referrer that is being sent via network connections. You should audit the third parties. There have been a lot of cases recently. MakeCart is one of the popular examples, where because companies are not using CSP headers and SRI headers, third parties can be hacked and then they can be used to steal data on your website. Users need to be informed if a certain third party can potentially have access to private data because of your website. For example, in case of Emirates, I showed you 14 third parties were able to access my passport information. Now we don't know whether they do access it or do not access it. There is no way as a user I know about that. So these things need to be laid down upfront in the privacy policies. Then a lot of the marketing emails that we send, we usually use a lot of marketing mailing campaign management solutions like MailChimp and stuff to forward the emails. A lot of the times, these email forwarders themselves do not have HTTPS. Second, we send these tokens, sensitive information over the URLs via these mail sending companies. That means we are also sharing the user's private data with these companies, and we should control that itself. The next part is what if you want to design a service from scratch, and what can we do to solve, let's say, the use case which we showed earlier of solving unique visitors, but doing it in a more privacy friendly manner, right? So we like to call this approach as a green alternative. So we would say, because we identified that the problem earlier was all the data was being sent to the server side with an identifier, which meant that server can now link messages, multiple messages with this ID. Let's remove that ID and let's move the aggregation per user on the user's browser instead of doing it on the server side, right? Now, you could argue that since Clips is a browser and we have our own, because it's a browser, we can do it. But thanks to HTML5 and local storage, actually, you can do it with basic access of JavaScript itself. So let's say, let's try and build a service called Green Tracker. So basically, what Green Tracker does is it gives you a code snippet that you can embed in your website. It works inside an iframe, so it does not have access to your main document. And whenever the page has to send a message, it will send via some post message. Now, how Green Tracker differentiates from the others is, let me walk you through this example. So what happens is, let's say again you are spiegel.de. On the blue is the blue is the Google Analytics backend, and the green side is Green Analytics backend. And here is the browser which loads spiegel.de, which has, let's say, first Google Analytics, and on the right side, an implementation of Green Analytics. Now, when the user visits the website, the third-party script is loaded on both the occasions. In case of Google Analytics, it generates the same combination of query parameters, which is viewport resolution and the IP and the URL that the user visits. In case of Green Analytics, we first generate, we check the local storage, whether we have seen this message before or not. If not, then it will generate two messages, visit and unique visit. And then it will update the local storage that at this point, we saw this URL, spiegel.de/xyz. It's a unique visit and the timestamp at which we had seen this. And now, in case of Google, it will send the message as is, but in case of Green Analytics, it will only send two parts of the message. One is the URL and the other is visit and unique visit. And then if you do the counts on the server side, you will still get the same output, which is one visitor and one unique visitor. Now let's say the user visits again. Google Analytics loads the script, Green Analytics loads the scripts on the page, and Google Analytics will send the data as is. But in case of Green Analytics, we will check the local storage that we have already sent a unique visit message. Hence, we are not supposed to send a unique visit message. And the only thing that will be sent in this case is a visit message. And now when you do the MapReduce job again on the server side, you will still be able to get the same response, which is it was one unique visitor who visited the website twice. Now, you could argue that this is a very trivial example, like counting uniques is not that difficult. We have to do more use cases like recommendations and goal conversions and etc. So that's why in year 2016, Clicks actually built own version of Google Analytics, which we call Green Analytics, which solves the top 10 use cases of what Google Analytics wants to solve, but all based on the client-side approach. We'd have no plans to become our own analytics company, but we just wanted to demonstrate that how it is totally possible to do client-side aggregation and yet solve your genuine use cases of doing analytics and stuff. And there's also a paper available on it. You can find the link for this in the repository itself. That said, that's not the only thing that we've been doing. All our data collection efforts are based on the simple principle that whenever you have to do aggregation per user, it needs to happen on the client side and not on the server side. Apart from that, we are also heavily invested in building transparency tools for the users. For example, you can check whotracks.me, which is basically a website which showcases how many trackers are present on a particular website. You can check the tool Local Sheriff, which helps you analyze your local history and see how your data is being leaked to a lot of third parties. So in the end, I would like to say like it's not trivial to do privacy by design, but if you change your mindset and you as developers become more responsible, it is totally possible to solve the use cases in a privacy friendly manner rather than having to collect everything and send it back home. And these are some of the references that I would really like if you go through them, which are basically our blog posts, our research papers that are there for people to consume. And in the end, I would just like to end with this note, like, unless your actual use case is to sell your users data or to snoop upon the users on the internet, you can build technologies that are totally privacy friendly, and you do not have to leak users data everywhere or collect everything that has been done on the web. So thank you for listening. You can send the questions right now, I think, or you can email me or send me questions on via DM on Twitter itself. Thank you so much.
Uh, that's a great talk, Konak. I mean, I would like to ask a question that most people would, ask is that, being a browser-based company, so the first thing is that after learning the talk, most people will be asking, like, how do you handle end users' privacy when using your product? Because that's what most people would be asking. Like,
Sure.
since you do, because you do get a lot of end users data if they're using the products. Like,
Right.
what are the practices that you use to make sure that you do you collect metadata or any specific data? Because since you have mentioned all this uh, cookies and stuff, so how do you implement these solutions in your product to make sure it is different from other
Right.
sorts of services they provide online?
Right. Um, so should I repeat the question or it's fine?
I mean, it's fine, probably.
Okay. Okay. So basically, the point is how do we ourselves prevent clicks from collecting such data? And like we follow a very basic principle at the design layer itself that if you are sending a data back home, can that data be connected with some other data being sent before or after this message? So first
Yeah.
of all, the thing that we need to solve is no two messages can be linked on the backend, which is Clicks in this case. And even any engineer at Clicks who has access to the data stream cannot even potentially correlate that these two messages are coming from the same machine. Now that in itself is a hard problem to solve. and we've achieved a lot in terms of solving that problem. So, for example, mm, we ensure like there are a lot of small things that I can share. For example, whenever the data is being sent from the client side to the backend, we never batch the messages that are being sent, because even if you remove any identifier like cookie, but if you, let's say, send a batch of 10 messages together to the server, I can still correlate that these 10 messages are coming as a batch. That means it happened on the same machine, right? Now, once you remove this, then you can say you can still do correlation based on the IP and network fingerprint. And that's why we have this project called Human Web Proxy Network. So in the resources, if you take a look at the last paper, which we published last month, which is basically how we route the data that we collect through a set of proxies, and that does not that prevents clicks from doing network level fingerprinting, and also prevents us from being getting attacked, because then people can just send us fake data, that because you do not know where the data is coming from, so we can just inject fake data with you. Similarly, on the question that you asked, how does clicks ensure that we are not collecting private data in itself, I would really emphasize to go through this link. It's basically what we call human web, which is basically both technology and a philosophy in clicks of doing client-side aggregation and how to send data in a safe way back home so that you cannot correlate multiple messages coming in. Hello.